So the last thing we're going to look at in this, this revisit of calculus, if you like, is what we call the primitive function. So if we know the equation of a tangent, what was the equation of the original curve? So up at this stage we've been saying, hey, here's the equation of the curve. What's the equation of tangent? This is going back the other way. Remember, all we've been dealing with at the moment really are polynomials. And we know that when we differentiate a polynomial, we bring the power down and we take one off the power. So logically, to go back, instead of taking one from the power, we should add one to the power. So hence we add one. And instead of multiplying by the power, we divide by the power. But it's the new power that we divide by, not the one that's originally there. Add one to the power over that power. So if my derivative is 3x to the power of 4, then it must have come from 3x to the power of 5 over 5. Add 1 to the power, 5, over that power. If you're ever unsure, all you've got to do is differentiate your answer and you should get back to where you started from. But notice the plus a constant, because there's the different bit. Because you'll recall that if you differentiate a constant number, you get 0. So therefore, if you're going back the other way, if you have 0, it's quite possible it came from a constant. Now we don't know what the constant is unless we got more information. So we just put plus some constant. It might be the constant 0, but some constant would be there. Just like with differentiation, we just do each individual term as it comes. So 6x cubed, add 1 to the power 4 over the power 4. 5x squared, add 1 to the power 3 over the power 3. X, add 1 to the power squared over the power 2. The constant 2, well, I suppose technically if you think about it, that's 2x to the power of 0. So add 1 to the power, it becomes 2x over 1. And then of course there might be some constant there as well. A little bit of tidying up there. The 6 on 4 becomes 3 on 2. It's all right. So let's go back to the original question that we posed. If we know the equation of the tangent, well, they haven't actually called it the equation of the tangent here. They've said find the equation of the curve. We know it goes through the point 1, 1. It has a gradient function. A gradient function. So that's the function that finds the gradient. That's just a fancy way of saying the derivative. Because if you remember, the derivative is the function that found the gradient. So what they're actually telling me is the derivative is 2x plus 3. I'll call it dy dx in this case. So we want to find the equation of the curve. So y will be add 1 to the power over the power, x squared plus 3x plus some constant. But now we've got additional information. We know that this curve goes through the point 1, 1. So I can substitute those values in and calculate the constant. And constant turns out to be -3 for this one. So that means the original curve was x squared plus 3x minus 3. And that's what we call the primitive function. Okay.